recorded the whole thing in the morning.
The data acquisition system that we're going to use is called LabQuest, and it's pretty easy to set up. And all the LabQuest system allows you to do is it just monitors the temperature at regular time intervals. So we're going to be taking the temperatures every 1 minute. And so as we monitor the hot water, okay, first thing is we heat up the water on the hot plate, we measure it in a grad cylinder, and then we pour it into the styrofoam cup. Okay, once it's poured into the styrofoam cup, it's going to stay there. And so once we get in the styrofoam cup, that's when we're going to start monitoring the temperature with our LabQuest data system. And so here's the hot water in the styrofoam cup. Now, if it's in the cup, then it should just cool nice and slowly, right? Versus if we're manipulating the water, you know, it's going to cool rapidly when it hits the grad cylinder and everything else. And so we're just going to take temperature readings every minute to see how it cools in the styrofoam cup. You know, and it should have a pretty secure lid. And so we're going to collect 5 minutes worth of data here, and we see it cools in a nice, what is that, linear or non-linear? But it turns out that when we look at cooling, you know, cooling can be fitted to a mathematical equation. A mathematical equation is called Newton's law of cooling. Have you heard of Newton's law of cooling? Newton's law of cooling is just, you know, how things cool down. And it turns out it's not linear. You know, when you have objects that are cooling, it's non-linear. That is, the hotter they are, the faster they cool. The closer they get to room temperature, the slower they cool. So we see a non-linear curve like this. What we want to do is we want to just kind of see a part of that curve here, so that what we can do is we can extrapolate this out. Here. Now the cold water is very close to room temperature. It might warm up a little bit because out of the tap it might be a little cooler, or it might not. Maybe it's at room temperature out of the tap. And so we don't expect much to happen with the cold water, but we'll still monitor it just in case it comes out of the tap colder than the room. It'll warm up a little bit, right? All right, then we monitor this for 5 minutes, and then at minute 6, we're going to open the lid for the cold water, and then we're going to crack open the lid for the hot water. We don't want to leave the lid open for very long,